Hello. In the previous recording I explained example 3.4, and remember this is 2D, so you only have some of the forces in X and some of the forces in Y. And now we'll have example 3.5. This is a 3D problem. You have a 90-pound weight on this cable, and you also have a spring, and it gives you the stiffness of the spring, which is, or the spring constant, same thing, 500 pounds per foot. So you need to find out two things. You need to find the force in the cable, in all of the cables, and the stretch S. Now remember that the stretch is the unstretched length minus the unstretched length, okay, or L minus L prime. But in this case you only have to find the stretch, because they don't give you any other information on the unstretched or stretched length. Okay, so you can only calculate the stretch. So a couple of things to note here are that here this cable D is in the XY plane, so this is in the XY, no Z coordinates, and then this here, this cable AC, it's in the XZ coordinates, so it has no Y coordinates. Okay, so this is Y and this is Z, so it makes it a little easier. Okay, so let's go ahead and solve this. This is sort of the free body diagram. It's harder to draw this, but we'll presume this is my direction to do my some of the forces in X, some of the forces in Y. So remember, it's equilibrium from the forces in X equals 0, and in this case this is the direction, the positive direction for X. And in X we have the force or the tension. You can either do it either way, force D, or you can call it AD, but everything starts at A. So force D, and then in X, okay, so you can see it as here, you can either do 30 or 60 here. So we can do FD and then do sine of 30 or cosine of 60, and this would be positive. And then we have the other force is FZ, I mean FC, not FZ, FC, and we have FC, and then the component here along X would be 4/5. So we have 4/5, and this is negative, and it equals 0. So I have all my forces in X. Let's do some of the forces in Y equals 0, and this is what will be our positive. So we have FD again, but then cosine of 30 degrees, and this is negative. And then I have the force in B, which is the spring, equals 0. So this is my second equation, this is my first equation, second equation, and my third equation would be sum of the forces in Z equals 0, and here is my positive Z. So I have FC, and then in this case I have the vertical component, which would be 3/5, and this is positive, and then minus 90. equals 0. And this is the third equation. So you have three equations, three unknowns. You have FC, FD, and FB. The first thing you do is to look at the equations that you have and how you can solve them more easily. And so here, if I look at equation 3, I will get FC. Then once I have FC, I go to equation, this is my second step, because I know FC, then I can calculate FD. And once I have FD, then I go here to the second equation and calculate FB. Okay? So that is the procedure. Make sure that you stop the video and do those calculations. So your FC equals 150 pounds. Your FD equals 240 pounds. And your FB equals 207.8 pounds. And FB is the one that has the spring. So this is the first answer to the first question, which is what are the forces? And now you have to calculate the spring stretch. So remember that then for the spring, F equals K times S, and the force of course is 207.8. The K was given as 500, and this is in pounds, 500 pounds per foot, times the stretch, which is in feet, so that's what cancels. So the stretch equals 0.416 feet. You have to be really careful in your FE exam, and of course in your exam, because here is given in feet, but they can ask for an answer in inches. So the units are very important. I hope this helps. Thank you for your attention.